Okay, time for the next topic, which is derivatives. Now, derivatives are actually pretty pleasant to solve in the sense that there are only a couple of main rules that you need to follow, and then all of the problems are solved similarly. Unlike limits, where there might be a couple of totally different strategies, here it's like just, chain rule, and quotient rule and product rule, and that's more or less it. The tricky part about derivatives is that you need to be very careful with your calculations, right? Because it's easy to mess up something easy. Okay, so conceptually easy, computationally could be slightly harder, but not too hard, right? Okay, so we're given that function and we need to find its derivative. So I'll just copy it first. That's x squared minus 3x plus 1 over x cubed plus 2x plus 1. Okay? So now, because we have a fraction, of course, in order to get the derivative, we would need the quotient rule, right? I don't really remember in terms of like signature and everything, but I look at it this way. So I have some expression in the numerator, and then I have some other expression in the denominator. So how do I calculate the derivative? I start with the derivative of the yellow expression, okay? Let me just write equals. Okay, so that's the derivative of the yellow expression. You know how the prime means derivative. Times just the regular blue expression. So the first time you start with the derivative of the top times the regular bottom expression. Then I have a minus, and then I do nearly the same thing, but now I move the derivative sign. So now the second time I'll take the derivative of the blue expression, okay? So I still keep both, right? So I have x squared minus 3x plus 1 times x cubed plus 2x plus 1, but this time the derivative is for the second expression, okay? And then I simply divide by the bottom expression, the denominator, squared. That's how the formula goes, right? So x cubed plus 2x plus 1 squared. And that's your quotient rule, okay? So once again, you start with the numerator and you take the derivative, multiply by the regular denominator. From this, you subtract the same thing, but you just change the position of the derivative, right? And then you divide by the denominator squared. That's something you need to remember in order to be able to solve derivatives. Okay, and from here, how do we calculate the derivative? Because we have some like summation and subtraction here for the first thing, it's quite easy to calculate, right? There's no inner product rule or anything. You just take the derivative of the first member. So the exponent comes down before the x, right? So it's gonna be 2x. And then you subtract 1 from the exponent. So it's gonna be exponent 1, but I don't even need to write it, okay? Minus, now I have it's not written, but this is exponent 1. So I bring it down. So that would be 3 times 1 technically. But again, the 1 doesn't change anything. So I'm just going to copy the coefficient 3. And then it should be x to the 0th power, right? Because when I subtract 1 from this, I get 0. But again, anything to the 0th power is just 1. So I'm not even going to write it. And here I just have a constant. Constants derivatives are 0, so I don't even need to consider this, okay? So that's the first derivative that I'm calculating. Lucky us, this we just copy, right? We don't need to calculate the derivative here, so that's x cubed plus 2x plus 1 minus, we keep copying, that's so nice, x squared minus 3x plus 1. And now I need to calculate the derivative of this thing. Same rule. That's the cool thing about derivatives. It's the same rules over and over and over again. So I take the exponent, I bring it down, okay? 3. Then I copy the x, but the new exponent would be the old one minus 1. So it would be 2 now. Plus, this has an unwritten exponent of 1. So I bring down the 1, multiply by 2, but this is just 2. And then I would have x to the 0th power, because 1 minus 1 is 0, but I don't even write this, because this is just 1. And then the derivative of constant is 0. So I am wrapping up here, okay? That's the numerator that I got. And the denominator, again, that's a nice thing because we don't have to calculate anything. I just keep rewriting it. You see what I mean? It's not complicated, but there's a lot of, like, it's just long expressions, and you need to be careful because if you make even like a minor mistake, it's gonna affect the whole end result. All right, let's keep going. So now this is just basic high school algebra, maybe even like secondary school algebra. This is not calculus anymore. We are past the calculus phase, and now it's just calculations. But you still need to be mindful because I cannot tell you how many times I've made like super dumb mistakes with simple calculations. So I just start expanding here, right? So first terms, that's gonna be 2x to the fourth plus these two, that's gonna be 4x squared plus the product of these two, which is 2x. And then I start here. These two, that's minus 3x cubed. Oops, hold on. Then I need these two, right? So that's minus 6x. And then I need these two, which is minus 3. That's my first expression here. Minus, and now I really, really recommend still keeping the braces here when doing the multiplication and then applying the minus sign. If you try to do both at the same time, it's super easy to trip up. So let's just keep the sign outside of the brackets, right? And just calculate that thing inside. So I'm going to have these two first. So that's going to be 3x to the fourth plus 2x cubed minus 9x cubed minus 6x. I'm not gonna keep circling, but I trust you that you know how to do this. So minus 6x plus 3x squared plus 2. Once again, everything I'm doing here is just expanding the brackets, right? That's what I'm doing. There's no calculus here, don't worry about it. And then in the denominator, wow, what a long expression. In the denominator, I keep this like that. You could expand it, but it's slightly harder, so just keep it at that. Okay? And I'll keep going. We need to further expand. So these will remain unchanged now. I could, I guess, just sum these two because they're all x's, just x to the first. So you have 2x to the fourth plus 4x to the second minus minus 4x. You see what I mean? Minus 4x when I add these two, minus 3x cubed minus 3. And now at this point I will start changing the signs of all of these. Why will I change the signs? Because there's a minus in front, okay? So that's going to be minus 3x to the fourth minus 2x squared plus 9x cubed plus 6x minus 3x squared minus 2, okay? That entire thing over x cubed plus 2x plus 1 squared, all right? And now we are to the point where we need to do the very dull task of just combining terms that have the same power, right? So let's circle. I'm going to be using different colors so that it's easier for you to track. So you have 4x to the fourth minus 3x to the fourth, and that's it, specifically for x to the fourth. So that would be minus x to the fourth. Then moving on to power number 3. So I have minus 3x cubed and I have 9x cubed, and that's it, okay? So that's going to be plus 6x cubed. Moving on, we have x squared. So we have 4x squared and then minus 2x squared and then minus 3x squared. So that's going to be 4x squared minus 5x squared, which is minus x squared. And then we have just a bit left. We have minus 4x plus 6x, so that's plus 2x. And the very last thing here is minus 3 minus 2, which is minus 5. Whew, finally, that's annoying. So now the denominator I'm not going to change. Again, you can just leave it at that. x cubed plus 2x plus 1 squared. And actually, that's your final answer. You don't need to do any further simplification. You have combined all of your I don't know how the word works, but you have combined all of your terms that have the same power. You could again expand the denominator, but you don't have to. I typically leave it at that, and I leave it as my final answer.